Okay, we're starting our unit on motion and forces. So we're going to be learning about speed and acceleration. Fortunately, we never see a speed sign that gives you an infinite speed limit. Okay, so today our essential question is, how do we evaluate if matter is in motion? How do we know if it's in motion? We have two learning targets today, learning targets 11 and 12. You will be able to identify and explain when an object is in motion, understand the difference between distance and displacement. You'll also be able to calculate speed and distinguish between the different types of speed graphs. Okay, so in order to figure out if matter is in motion, we need to know that all matter is constantly in motion. Because remember, our last unit we talked about matter being made up of atoms and particles that are always in motion. They always have kinetic energy, even if they're in a solid, liquid, or gas. So how do we know if that motion actually moves? Well, in order to determine if something has motion, you have to have a reference point. So an object changes position if it moves relative to a reference point. So the reference point is some stationary object. For example, an object, I already said that. If we've got this tree is going to be our point of reference. And if you're in a car and the tree is not moving, if you move in relationship to a stationary object like this tree, then that's how we know something is in motion. We know the car is in motion because its distance from the tree to the car is changing. So that's how we know if an object is in motion relative to a reference point. Okay, just a couple things when I mentioned how we know if something's in motion. If distance changes relative to a reference point, and remember distance is the length traveled. Displacement, however, is distance plus direction. So, for example, if you travel from your house to your friend's house and it's 3 miles, that's your distance. And it also is your displacement, 3 miles east, because that's the direction you went. Displacement is also the shortest possible path from start to finish. Okay, to understand the difference between distance and displacement, let's say that you have two different paths. You have Alan's path and Eve's path, and they're going from the west gate to the east gate. The path that Alan traveled, you can see that's represented by all these little squiggly lines. You could calculate the distance of Alan's path, and his distance would obviously be longer from Eva's path because he maybe took the scenic route. Now, from the west gate to the east gate, the quickest possible distance is 100 meters. So the displacement is 100 meters east. Okay, Alan has a different distance than Eva, but they both have the same displacement. Displacement has nothing to do with the actual path somebody takes. It has to do with the shortest possible distance from start to finish. So displacement for both Eva and Alan is 100 meters. For distance, Alan's path is probably more like 200 meters compared to Eva's distance of 100 meters. So hope that explains the difference between distance and displacement. Okay, so when we deal with motion, we always want to calculate the speed because we always want to know how fast matter is traveling. So speed is the distance traveled in a certain amount of time. The formula to calculate speed is distance divided by time. The units are going to be in meters per second because meters is the base unit to measure distance. Seconds is a base unit to measure time. So meters per second is the unit for speed. Now, a lot of times, especially when we are measuring speed over a long period of time, let's say, for example, when you're running a race, like maybe running the mile, we know that when we run a mile, which is 4 laps around a track, we don't run every single lap the same speed because we get tired toward the end. So a lot of times we calculate the average speed. So that's when the change in speed happens. So we take the average. So we take the total distance divided by the total time. And we'll do an example right now to show you how that works. Let me get to it. Okay, so Two students meet at a school dance at 5 p.m. Each student uses a different means of transportation to get there. Student A leaves at 4 p.m. and travels at 10 kilometers by bicycle. Student B leaves at 3 p.m. and rides his skateboard for 20 kilometers. What is the average speed of each student? Which student traveled faster? Okay, so first thing we have to do for student A is determine the total distance traveled. Okay, student A, it says traveled 10 kilometers. Now let's look at the time. Both students arrived at the dance at 5. Student A leaves at 4, so 4 to 5 is 1 hour. So we've got 10 kilometers as the distance, 1 hour is the time. Student B traveled 20 kilometers, so a little bit farther away than student A. The time it took student B was from 3 p.m. to 5 p.m., so for 2 hours. So if we set up our math, this total distance divided by time. Okay, student A, total distance is 10 kilometers. Total time is 1 hour. So if we take our distance divided by our time, 10 divided by 1, we get a speed for student A of 10 kilometers per hour. Notice we take the units for distance and for time, and that's your units for speed. Student B traveled 20 kilometers in 2 hours. So student B, if we divide 20 divided by 2, also has a speed of 10 kilometers per hour. So both students traveled at the same speed. Okay, another way that we can describe speed is called instantaneous speed. That is the speed of an object at one instant in time. So, for example, if you're driving in your car and you look at the speedometer, it says you're going 45 miles per hour, that's instantaneous speed. Another example right here, okay, this car is traveling. If I wanted to know at what is his speed exactly at 2 miles, you can calculate that by waiting until it gets to look at the time. So 2 miles divided by 0.10 hours, that's instantaneous speed. Now if we wanted average speed, we would take the total distance traveled, which is 5 miles, over the total time, which is 0.2 hours or 20 minutes. So that's the difference between instantaneous and average speed. Instantaneous speed is the speed at one particular point in time. Average speed is total distance divided by total time. Okay, now we're going to do a lab with graphing motion, but I wanted to go over what you will start to see when you start graphing motion. When we look at our speed graphs, when we graph our motion, because speed is distance divided by time, we always have a certain way that we label our graphs. Okay, so always on the x-axis is going to be time, and then what's going to always be on the y-axis, what we measure, is going to be distance. So distance is always on the y-axis, time is always on the x-axis, and you can see speed equals distance divided by time. Now since time is on the y-axis, we are always going to have a line graph to graph our motion for speed. Okay, so let's take a look at these graphs. If something is not moving, if matter is not moving, then you're going to see a graph that looks like this. It's just a straight line all the way across. Here's the reason why. If your distance, let's say you're at 5 meters away from your house and you stop to take a break. So if this distance right here is 5 meters, and then we just measure over time, and after 1 second, 2 seconds, 3 seconds, you're still at 5 meters, then that means you have not moved. So no speed on a distance versus time graph is a horizontal line. Now, constant speed means that you're traveling at the same speed. It's kind of like cruise control in a car. So if you're driving a car a long distance, that won't happen for you guys for a really long time until you get to high school and you get your license. But for example, when I drive home to Texas, my husband and I like to put it on cruise control so we don't have to keep putting the pedal to the metal. So we will set our cruise control at, because the speed limits are a little faster out east, we would set our cruise control around 65, 70 miles per hour. That means our car is going to just keep going at that same speed. That's constant speed. So when you look at a graph, okay, constant speed is represented by a straight line The steepness of the slope determines how fast that constant speed is. So, for example, if I have a constant speed that looks like this, pretend that's a straight, there we go, straight line. That the green is a faster constant speed than the yellow because it's a steeper line. Now, you're probably looking at this next one, so well, what's this mean? Okay, on this one, this 0 point right here means your start. This is your finish. So what this means, when it goes back down, that means you are going back home. So this would be you traveling to your friend's house as a constant speed. You reach your friend's house, and then you're going to travel back home, back to the start, at a constant speed. Okay, so those are what the graphs look like for no speed and constant speed. Now, if you start increasing and decreasing your speed, so you're not traveling at a constant speed, increasing speed is a curved line that goes up. And that just straightened it, which I didn't want to do. So that would be constant speed in green. Let's see if I can get it off. So increasing speed is just a curved line that goes up, showing that your speed is increasing. Decreasing speed is the opposite, you're going down, and also back to start. Okay, so that's what increasing and decreasing speed looks like. You're going to want to make sure that you draw all these graphs in your notes. Okay, the last thing we're going to talk about is velocity. Velocity is the same thing as speed, except it includes direction. So it's calculated the same way, distance divided by time. You just have direction. For example, in Texas, we have a lot of tornadoes. If I'm at my house in Texas, at my parents' house in Texas, and I hear on the weather station that there is a tornado traveling at a certain amount of miles per hour, if they don't tell me the direction that the tornado's moving, then I have no idea if I'm in the path of the tornado. So that's why speed usually always contains direction, and we call that velocity. Okay, so hopefully by now we have a better understanding of the difference between distance versus displacement. You should now be able to calculate speed and be able to look at the different speed graphs and classify them using your notes.